So every function has a set of numbers you can input. So the set of numbers input. So they're the things you're allowed, or maybe another way to think of that is the things you are allowed to plug in. Plug into the function. Some functions are really nice and they'll let you plug in any old number, even imaginary or complex numbers. Some functions are finicky and they only take certain values. And some take most things but not others. So depending on what our rule is, we'll see some functions that allow that. And hopefully get a better feel for what inputs are, what our allowed inputs are. And then the range are just all the possible outputs. Or maybe another way, maybe all the y's. If we're thinking, if it's just a two-dimensional function. Possible y values. The domain and range of function, if you are savvy algebraically, then we can determine what the domain and range is without really much of a graph. We know something about some special kinds of functions called parent functions, which you probably have heard about throughout your algebra careers. I think they're easier to see if you can graph them and get a picture of what some of these functions are. So oftentimes it's really handy to use a graphing calculator, or if there's a picture provided, use the picture to try to figure out what the domain and what the range of things might be. We just figure out what x's were we able to plug in, and then we see what y's we got back out. And that's all there is. Okay. So for example, I have no idea what the equation of this relation is, but I can determine if it actually is a function or not. And I can determine what could be plugged in and what could come out. So for example, I'll try to use some colors here. So first of all, if I want to know what the domain is, I try to figure out what all the possible x's are. And this graph isn't even labeled. So even in the event of that, I can still find what's the farthest left x ever gets. And it looks like it's whatever this value is. I don't know, maybe I'll call that, how about A? And then from A to the right, it looks like my function travels. I keep plugging in numbers. I get good stuff until the bitter end. And whatever this value happened to be. The domain is anything in between these two things. I can plug in any x on the number line between that first value and that last value, A and B. So in this case, the domain, in this case, would be x is stuck between, it looks like it's somewhere between that first value and the last value, is how I would write the domain and range for this kind of crazy function. It has no given value. For the range, I do the same thing, but with the y's. So where's the smallest y going to occur? and there's not a number, so you're gonna have to kind of describe it. Kind of this little trophy area down here, like down at the bottom. So, I need another letter that's not A or B.
C.
Oh, we're real creative today. C. And then where do you think where's the biggest Y we're going to get back out? With this little crest thing here. Go on a limb and say we're going to go D. So the range of this function is any of the y's that are between C and D, because somewhere along here you can slide over and hit the graph. So one of those y's is a part of this. So our range is y is stuck somewhere between C and D in this case. Is this thing a function? How do you know? I mean, this thing definitely relates x's and y's. Like, you hand me an x somewhere between a and b, and I'll tell you what the y is, or y. How do you know, is it a function or not? What distinguishes any old relation from a function? For every input, there's exactly one output. So on a graph, how do you tell it? For every input I hand you, there's only one output. You know, remember what that fun test is called? Called the vertical line test. If you can draw a vertical line through any point and it only hits the graph once, function. So I would say, it looks to me like no matter how I draw a vertical line, I'm only going to hit this line once. So no matter how I slice this going vertically, I'm only going to hit this graph once. So I'd say yes, this is a function because it passes the vertical line test. Have you seen the vertical line test before? At least heard of the thing? I hope. I think we talked about it in Algebra 1. I don't remember off the top of my head, but I think so. Okay. Can you think of, so this was a function that is actually, this weird function is actually between two values. If our function is kind of stuck between two values, we say this function is what's called bounded. Similarly, moreover, if the range is stuck between two values, we call it bounded. Can you think of any? Can you think of any functions you've maybe seen in the past that are maybe you would say unbounded, either up or down? Can you think of any functions that may be what's called unbounded? Any functions that go on and on and on forever in either the positive y or the minus y? I know you've seen them. Maybe we just don't remember some of the names. Or when you think of an unbounded function, and this is not a trick question, you shouldn't have to dig deep into your memories of various functions. Which one? Square root of x is in fact unbounded in the upward direction. So just square root of x, its graph looks something like that. That goes up and up and up forever. Very slowly in a sense, but it goes up and up forever. This would be unbounded in the positive y direction. I'm thinking of a function that is unbounded both up and down and is even simpler than square root of x. Why? Anyone remember how you graph this thing? This has what, a slope of 1 and a y-intercept of 1. So it hits the y-axis here. And it goes over 1, up 1. This function goes down and down and down forever, and then goes up and up and up forever. This would be unbounded. This goes forever in both directions. It actually is unbounded in terms of the domain as well. Well, how would you describe the domain of this crazy function? Do you think? You're allowed to plug in any real number, and then what's the range? What y's do you get back up? Any all real number. So the domain and range for this little guy, this could be all real numbers. There's a couple ways to write that. I like the symbol for the real numbers, which is this kind of boldface R. You could get real fancy, and you could say something like this. It's stuck between negative infinity and infinity. Maybe if you want to write something like that. I don't know. And the range, similar, would be all real numbers, or something like that. Just as a review. So actually, these simple functions have huge domains, which can be good for us. Square roots tend to have a restricted domain, because what numbers can't you plug in to, say, the square root? Negatives. So this domain of this square root function would be anything that's not negative or greater than or equal to 0. It'll be a domain for the square root function. Okay, so I had some other ones we look at. So here's some other functions. So state domain and range. Oh, and then estimate any zeros. How might one go about what is a zero of a function? More review vocab words. What is a zero of a function? In my mind, there's really two choices. It's either when you plug in 0, what do you get? Or when I plugged in something, the answer was 0. Those are I don't know what other possible meaning 0 could have. So which one of the two do you think it is? When I plug in 0 or when I get 0 out? When you get 0 out is the correct answer. Sorry, Thomas. The zeros of a function are x values that return about the answer 0. So they're a number that I plug in. When I run it through my function, I get 0. If the function's value is 0, where will that be on a graph? And where? There's plenty of lines out there. Which one? The x-axis. The x-axis. So if I wanted to estimate zeros, one easy way to do that might be to graph it. Say, with a graphing utility, like a calculator, that are all over there that you're free to borrow if you want, or if you have your own. And then estimate where it crosses the x-axis. Be a good idea. So if I wanted to estimate, state the domain and range of these various things, domain would be what x's can I plug in? And I'll just abbreviate domain with D because I'm lazy. What numbers are you allowed to input? Maybe a better question would be what numbers can't you input? So if I see a square root, what can't I have? Negatives underneath. So what I'd like to identify is what x's do bad things. What x's make that thing negative underneath? Anything under -1 can't have. So then if you can't have anything under -1, what can you have? -1 or bigger. So the domain for my first one better be, the things I am allowed to have would be any x that is bigger than or equal to -1. if you graph that on a calculator, you'd see that the graph doesn't show up to the left of -1, which is pretty neat. What y's will you get out, do you think? Generally, we start by just plugging in a couple values and see what happens. If you plug in -1, what's the answer? 0. What if I plugged in 0? What do you get? 1. If I plugged in 5, what do you get? No, sorry, not 5. 3. 3 would be better. 2. 3 plus 1 is 2. What kind of numbers do I see in the beginning? Greater than 0. Will I ever get a negative? You can't take the square root and get a negative value, so y better be bigger than 0. And if you were to, say, plot this in a graphing calculator, just a sketch, nothing fancy, just kind of a brief picture of what this thing looks like. So it looks something like this. Oh, thanks. That's pretty neat.
It's pretty neat. Hey, you guys are so alive right now.
What are the zeros? What x could I plug in to get 0? We already said it. Actually, it's pretty neat. -1. And that's the only one. Did we answer all of it? I think we did. Found the domain and range, found the zeros, and we sketched the graph. Again, this graph sketching, use your calculator. Just get something on your screen and try to transfer that thing over as best you can. If I say sketch, that's all it is a sketch. If I say graph the thing, you better have actual points, and it better be on graph paper, and you better justify all the things you're doing. Sketches are just sketches. They're just things that help us visualize. What's the next one? Anyone know what's the next one look like? Anyone know what this thing looks like? This was kind of weird.
It's a straight line.
Ooh, it's not a straight line, but it has something that looks.
Oh, does it go like that?
It does go just like that. It does go something like that. So Sean graphed it. Where was that thing that you thought was a straight line? Where is that actually at in your graph? Do you think?
What do you mean?
Like what value of x gives you that looks like a straight line on your graphic calculator? Do you think?
Oh, well, it's a negative. All right, a value of x.
Of x.
Oh, 0.
0? It did?
Well, it says 0.
A straight line?
Well, maybe that's not true. I don't know.
Maybe try zooming in.
Maybe I'm just being stupid.
I don't know. I wouldn't say stupid.
No.
First of all, is there any x's? What t's do bad things here? 4 does badness. Why is it so bad? Because divided by 0 is not really allowed, ever. It's undefined. So I can't divide by 0. So if we see a fraction of variables down below, the domain is going to be restricted because we can't plug in numbers that make us divide by 0. Are there any other x's that do bad things than 4 in this case? I don't think so. Like, there's no square roots, so you don't have to worry about negatives under there. And really, divided by 0 is the only other major pitfall. So the only x we're not allowed to plug in, actually, in this case, is 4. So how are we going to write the domain, do you think? How about the only x we can't write is 4? So we'll just say x is just not equal to 4. It's anything except 4. So we say that this actually never quite gets to 0. So the range, it gets really big as we saw in the graph, but it doesn't ever get to 0. So the range in this case, it never gets there. So it never quite gets to 0 in this case. It looks temptingly close. And it will get in fact, it'll get as arbitrarily close as you want it to be, but it never quite gets there. It gets super, super, super close.
I just have a question. So my graph's very similar.
Right, 0 is not even part of the range, so you can't ever get a 0 out. Sound good? I'd like you guys work with either on your own or with a partner, and let's try analyzing this last one on your own. So try to identify what the domain, what the range are, if there are any zeros, and then get a quick sketch of this thing. Use a calculator, or if you know what that graph looks like from memory or from years past, get a little sketch.